This is the Circular Economy Show by the Ellen MacArthur Foundation, where we develop and promote the idea of a circular economy, engage key actors in the system to make it happen, and mobilize system solutions at scale. My name is Laura, and I will be your host for this episode. We will be taking a deep dive into the built environment to discover how it works today, its impact on climate change, and also how the circular economy offers a solution to decarbonize this industry and address its climate impact. We will take you to the UK and Ghana and explore two examples that prove that there are better ways of designing, using, and making our buildings. I will also be joined by two special guests today who will be telling us their experience of working in this industry. We will hear from Grace Di Benedetto, who is a structural engineer at Arup, and also Eric Corey-Fried, who is the Senior Vice President of Sustainability at Canon Design and also the co-author of the book Circular Economy for Dummies. But why are we here talking about the built environment today? Well, here's a clip to help you understand why. So we have outlined three strategies in which the circular economy can help address the emissions that come from the built environment sector. But now let's get practical and let's hear from some of the examples from the people that are making this work in reality. First, let me take you some miles away from where I am now, and let's take a closer look at the building that is at the heart of London. This building is called 1 Triton Square. Next, we will hear from my conversation with Grace Di Benedetto, the structural engineer at Arup, who will be telling us all about designing for deconstruction and what some of the economical and environmental benefits of this approach are. Let's take a look. So thank you, Grace Di Benedetto, for being here with us today as part of our Circular Economy show by the Ellen MacArthur Foundation. I would like us to start the conversation by talking a little bit about something I read the other day. I was reading the BBC News and I saw this article that said that the UK's top engineers are urging the government to stop demolishing buildings. And I couldn't help but ask myself, why are we still doing it? So I was like, I need to ask this to Grace.
That's absolutely right. It is a big question. Why are we demolishing buildings today? From the outset, it seems like it doesn't make sense. We have these fantastic stores of materials that are high quality and valuable materials. We've spent millions of pounds to create these buildings. Why are we letting them become piles of rubble? And there are many reasons for it. The buildings that have been designed have not been designed to be taken apart. They've been designed to be ripped apart and crushed for landfill or for downgrading. So there's, at the moment, many logistical issues to actually deconstructing buildings as opposed to demolishing them. And there's also a really big challenge around, if we are to switch to deconstruction, what are the costs associated with that? And that can scare a lot of clients from, choosing deconstruction over demolition. So yeah, it's a really big subject. But I think the key item is at the design stage. So it's what our engineers and architects and designers can do to change from demolition to deconstruction.
And that's why we are here today, to hopefully give the audience a little bit of an overview of what that can look like in practice. So what does better design for buildings look like? And what specifically is design for deconstruction?
Sure. So design for deconstruction is a philosophy where buildings are designed intentionally for material recovery and reuse at the end of life. So, like I said, currently buildings not only have zero value at the end of life, they actually cost money to demolish and to process the waste. So instead, when we design for deconstruction, you have this fantastic ability to create buildings which act as these stockpiles of these valuable materials that can be easily taken apart and used in new buildings instead of virgin materials. And in doing that helps us to sort of chip away at the enormous amount of carbon emissions which are associated with the built environment. And in terms of actually doing this practically, the ideal deconstructible building is very similar to a Lego building. So we try and design components that are modular, connections that are reversible, just like Lego, and materials that are robust and reusable. And we want to try avoid using any paints or coatings that might be difficult to remove. And we want to ensure that the components of the building are easy to access, and there's a plan for how they can sort of safely be removed without damaging the item.
And I mean, you brought this up in your first answer, the importance of design, of the design stage, and how much of our environmental impact is determined by decisions that we made in that crucial design stage. And I mean, obviously, as you speak, it comes to mind that one of the benefits is probably reducing the amount of waste that the built environment produces. But what are other benefits that perhaps designing for deconstruction can have, economic or environmental, any kind of benefits?
Sure. So 11% of global carbon emissions is attributed to the carbon which is embodied in the materials that we use. So in designing for deconstruction, we are potentially opening up a stock of materials that can be reclaimed at the end of life and reused in new buildings, which then in turn reduces the carbon emissions associated with new buildings. And in terms of economic, in going for design for deconstruction, one of the challenges that's often cited is the increased use of labour at the end of life to deconstruct, in order to unbolt everything rather than just go through it with an earth mover. involves a lot more people, but that is a real great opportunity for job creation, as is, refurbishment of things that come out of existing buildings for reclamation is also a really labor-intensive process that can create jobs in the local economy.
And Grace, you work for Arup, and you obviously have a lot of experience working on the circular economy and the built environment. So let's talk a little bit about what is happening already. I know you have a building that our audience has seen before in a video called One Triton Square. What makes this building so special or different from others?
Sure. So to start with, it's a refurbishment project, which is something that's becoming much more common, but it is still perhaps not the norm. So that project, One Triton Square, is an existing building that was built in the 90s. And the client wanted to maximize the value of the site by increasing the floor area by around 70%. If we were doing business as usual, the design team would usually say like 70%. There's no way that we can make that happen without demolishing and rebuilding. But instead, they found an opportunity to retain much of the existing structure while adding new stories and infilling empty space. And ultimately, this resulted in 56% of the embodied carbon compared to a new build and demolition scheme. And that's sort of the in situ reuse story. But the part of it that I find really interesting and different is that rather than replacing the facade, which looked quite tired and perhaps dated, what they did is they dismantled it and transported around 3,000 square meters of it to a pop-up factory where each panel was inspected, cleaned, and had the gaskets replaced. And then it was installed back on the building, which resulted in a 66% saving in cost. And even things like paving and other roof materials were reused products from other demolished buildings.
This is a great example of dismantling a building and refurbishing and a great example of the circular economy. But are these options scalable at the moment?
Yeah, I mean, there's nothing about design for deconstruction, which means it can't be used on projects of any size. But there's definitely an education piece that needs to be done to develop guidance around design for deconstruction, not just for clients, but also for designers, contractors, demolition experts, so that they really understand the technicalities of achieving it. And I think to scale, we also need more case studies and more large-scale demonstrators that can really reassure stakeholders and insurers. And I think really a really big part of it, as with many circular economy interventions, is making sure that it's instigated early on in the project. So this really helps to sort of bake in a culture around circular design and kind of moving away from that linear consumption thinking. If you try to do design for deconstruction as a sort of bolt-on at the end of a project, it really isn't efficient and it doesn't quite work.
So we have to bring this thinking, this kind of bigger idea of the circular economy across the way that we design, we make, and we use materials and, well, everything around us, basically. So we've spoken a little bit about, reusing materials, the importance of design. I wonder as well, Grace, is there a market for recyclable steel or all these materials, cement, that are used in the construction industry? Is there a market at the moment, and what can we do to create a better one or better conditions?
Yeah, so it's in the UK, it's at its very early stages. There are some organisations which are ahead of the game in terms of providing reclaimed structural materials, for instance. For things like brick, that's been done for ages. That's a really common material to reclaim. But I think the challenge here is that you kind of put into this chicken and egg situation. So, for instance, if I wanted to get hold of 35 tonnes of reclaimed steel, I would really struggle to find that quantity of material in existence. And so I probably would think, I would maybe do a look online and I wouldn't find anything. And because of that, the people at the end of life, the demolition contractors and the salvagers, they don't see any demand for these materials. And so they don't think it's worth the additional effort to carefully deconstruct, to store and to refurbish the materials because they just don't see people who are wanting it.
But this shouldn't stop us, right, from designing for deconstruction, as you said in the beginning. We might not have, all the answers yet, but we have to start somewhere if we want to make this transformation possible.
That's absolutely right. Yeah, I think with many things in the circular economy, you often start to get almost a bit confused around the circularity of responsibilities. Why should we design for deconstruction when there's no market for it at the end? But it's funny because a while back I was making dinner and I got to thinking that someone must have invented the tin can before the tin opener. And I Googled it, and in fact, the tin opener was only brought to market some 50 years after the invention of the tin can. So the inventor designed it knowing that it was something transformational, but without having all the answers to know how it could be used. And like you said, Lara, in terms of circular economy and design for deconstruction, we shouldn't wait to have all the answers to start doing what's in our area of influence. Once we start doing what we can do, that will start the engine of the circular economy and it will make reuse more viable eventually.
Thank you, Grace. I think that is a great answer to finish this conversation. Thank you so much for being part of the Circular Economy Show.
Hi. This episode of the Circular Economy Show is part of our network workshop, an event that takes place twice a year and that's designed for and with the Foundation's network. These workshops provide a forum for circular economy insights and inspiration and enable network organizations to connect, learn, and collaborate with other circular economy professionals around the world. It's currently taking place online, so if your organization is part of the Ellen MacArthur Foundation's network, you can register now at community.emf.org. Thank you, and back to the studio.
One Triton Square is an example of better using an already existing building while eliminating waste and pollution and reusing building materials. Now, let's move from the UK to Ghana in West Africa to take a look at how the building process of some kindergartens was redesigned. Let's watch a video narrated by the person involved in the project, Hayley Greek, who is the social infrastructure lead at Arup International Development.
This was a project that we worked with a local NGO in Ghana called the Sabre Charitable Trust, who were focusing on supporting early childhood education. So the design approach that we took for this project was really an approach of kind of participatory design, where it was really shaped by the local needs and the local context in terms of the capacity that existed locally to build these schools, the materials that existed locally, and the understanding of construction. We really focused on the materials that we were using. So because this was a model school and it was to be replicated throughout Ghana, we really wanted to develop a design that could be adaptable to different contexts. So using local and renewable materials was key. So for example, we looked at using soil stabilized blocks instead of local concrete blocks. We looked at how we could improve the production of those soil stabilized blocks, and we actually had them tested against some of the concrete blocks that were made locally, and they came out twice as strong. We looked at different materials for kind of acoustic insulation, for example. So using one example that we used on some of the schools was coconut husks, which was a waste product from the coconut farmers that sold coconuts in the communities, and looking at kind of cement replacements in the concrete, for example, local cement replacements. The other approach that we looked at in terms of the kind of sustainable design approach was really designing the school that looked at the dimensions of the classroom and the dimensions of the key structural elements to ensure that there was minimal waste in the materials. So really understanding the availability of local materials, the lengths that, for example, reinforcement bars came in, the dimensions of timber components, so that we could design a school that had minimal waste. So I think the key opportunity on working on this project was to really kind of support local livelihoods and build capacity of local communities to allow them to not only build kind of a sustainable and safer school within their community, but also to use the construction techniques and the materials that we use to then go on and build other infrastructure within their communities and the surroundings. And the local teams are now fully to have full ownership on kind of constructing these schools and adapting them to different sites. Some have made and started their own kind of material manufacturing in local communities, like the saw blocks, or making acoustic insulation out of coconut husks or wood shavings. So the impact on, I think, the local livelihoods and the local community has been, in the communities that we've worked with, has been huge, and that continues to kind of happen each year as they roll this school out.
The way these kindergartens were built used an approach that accommodated local materials and reduced waste in the process. Through skills sharing and stakeholder engagement, local communities ensured that they used the materials around them and that they implemented the principles of the circular economy in their building process. Next up, we will hear from Eric Corey-Fried, who is the Senior Vice President of Sustainability at Canon Design and also the co-author of the book Circular Economy for Dummies. He will not only walk us through what is wrong with the current way we build, but he will also talk about how we can look at nature not only as an inspiration, but also the way we build buildings can also regenerate nature. One thing I've seen in one of your previous conversations is that you say that the way we build is wrong. What does this mean?
Stupid. I usually say it's stupid. Wrong is
even
too
better.
polite.
What does this mean?
Well, it's stupid. I mean, think about it. We build in the dumbest way. We make every single building a one-off prototype. Every single building is a bespoke masterpiece, and it's built by hand, one stick at a time, layer upon layer, with tons of joints, with no opportunities to really reclaim that, no understanding or context that building is going to be remodeled at some point in its lifetime, and no real understanding of where the carbon emissions were that went into making it, the operational emissions that are going to be caused from running it, and really no connection to the health of the occupants inside of it. So it's silly. And when I was a student, studying architecture, and I would, raise my hand and say, well, why do we do it that way if it's so damaging? The response was always, well, I don't know, we've always done it that way. And that's the worst answer you can get. If we know it's stupid and yet we've always done it that way, well, then surely there's something better that we can do. And that's what it really started to get my attention with the circular economy, because I really see it as a framework to use to really start to solve and address a lot of these problems that we're facing in the building industry.
And I mean, you just brought up the circular economy, which is obviously one of the topics I want to cover in this conversation with you. So when we talk about, we need to transform the built environment industry, what are sort of the first things that come up to you, for you?
There are so many issues and so many, I call them market failures, just across the board. But let's start with the big one, energy and its relationship to carbon. Buildings are responsible for more than half of the carbon emissions in our environment, right? If you factor in the construction, assembly, operation, and maintenance of buildings, it's more than half. So if we're going to solve this climate crisis, we have to change how we do all those things in our buildings, not just in the operations, but what we make them out of. And it's really hard to build a building today without concrete and steel. And yet concrete, steel, aluminum, and glass, those four materials alone are responsible for just a majority of these, embodied carbon emissions. And we really don't have viable solutions or alternatives to them yet. We're trying, but it's pretty slow going.
In a way, when we talk about the circular economy, we always bring up the three principles. So eliminating waste and pollution, circulating products and materials, and regenerating nature. What role, you mentioned this briefly, but what role does the circular economy play in addressing the emissions from the built environment sector?
Well, it depends on how you look at it. I really look at it in terms of taking this holistic life cycle approach to it. So for everything that we're putting into the building, what were the byproducts of extracting it? How is it delivered and installed? How is it maintained? And what are we going to do with it when we're done with it? So really just taking that holistic approach. One of the things that I do very often with clients is that I'll run them through this thing called the Resolve framework, which I didn't create. It's kind of a standard thing, but it just helps me kind of organize the questions of, okay, well, what, if recycling is actually not our top priority, but actually our bottom priority, and our first priority is to design out waste, that starts to really transform and rethink how we look at a building. I'll give you a dumb example. Let's say you're remodeling your bathroom, and let's say you pick out an 8-inch tile. Sorry, I'm American. I don't do metric, but we do an 8-inch tile. Well, shouldn't that bathroom also be some module of 8 inches? So that way the tiles space out evenly and you can avoid having a cut. It always drives me crazy when you're in a bathroom and you see that little extra sliver of tile because someone didn't plan well. Well, we can know that in advance. So we can design the bathroom on a module of 8 inches and get nice clean edges. That reduces waste. It also helps you with other things because everything in construction is basically on some module of 8 inches, right? Bricks, concrete, block, tiles, plywood, everything is based on that same module. And so if we design to the module, we can start to reduce waste in a very easy way and save cost at the same time. So there are many easy things that we can do, low-hanging fruit, that a lot of architects and builders haven't even addressed yet to really get us there.
And one of the key things in our previous conversation that you brought up was nature. You started talking to me about nature as kind of like almost like the technology that the built environment should use. So what do you mean by this? What can we learn from nature?
Well, this is quite an obsession of mine. Nature is the ultimate innovation factory, really. Right? 3.8 billion years of research and development in nature. And think about what nature does on a daily basis. Nature is able to produce energy, sequester carbon, manufacture oxygen, fix nitrogen into the soil, provide food, provide habitat for thousands of species. And it does all this without waste. It does all this without massive amounts of heat, right? It does it in a beautifully balanced equilibrium-based loop. So there's a lot that we can learn from nature, not even getting into DNA and biology and all that other stuff. Just looking at the normal systemic ecosystem services of nature is just already kind of remarkable. There are times when I just, walk around in awe constantly at what nature's doing for us for free that we couldn't even possibly start to figure out how to do on our own or even pay for. So if we start to look at nature as a technology, that starts to change maybe our relationship with it. It's not something that we squander. It's not something that we destroy. It's not something we consume, but rather that we work in harmony with.
So if you would imagine a building that has used nature as the technology, what would it look like and how would it be different from, the current buildings that we use?
Well, it wouldn't look that different than a tree. I mean, it might look different, but it wouldn't function that differently than a tree, meaning it would have roots deep into the ground to use the mass of the earth to create heat. It would have solar collectors all over the roof to collect energy from the sun and convert that into electricity. It would have the ability to sequester carbon in its finishes as opposed to producing carbon as a byproduct. It would be healthful and potentially would be able to grow and adapt over time as needed. And ideally, it would be able to provide a habitat for more than just humans, but for other species as well. That really is what we're after. And so that I kind of am describing a tree, not that we should all go live in a tree house, but rather think about nature as that technology that we can use as the model to do that. And we're just scratching the surface with being able to get there.
And if we know what what we already need to know from nature or about nature to make this happen, why can't we see this happening, let's say, at the scale that we need, but also what do we need? What are the sort of challenges or barriers keeping this from happening in reality?
Well, that's the depressing part, right? It goes back to the same answer that I got 30 years ago in architecture school, which is, well, I don't know, because we've always done it this way, right? You have what is it, $9 trillion construction industry or something insane that's very embedded and used to a certain way of building. And they know that it's flawed and they know it's not perfect, but it's what they know. And so getting them to change is difficult. In addition, we have a code system throughout the world that's really based on three main materials: stone, masonry, and steel, or I'm sorry, wood, masonry, and steel. And the code's written for that. And that makes total sense. But if you wanted to use something alternative to those big three, you'd have a fight on your hands. You'd have a bit of a challenge, and you'd have to demonstrate and prove that it meets these requirements. We have this now with a product called mass timber. It's really engineered wood, so it's a renewable resource. It's a carbon sink. It's engineered to be as strong as steel, but we've been slowly fighting with the code to get it to accept that it really has a great fire resistance rating because it's all engineered. It doesn't really burn. It's got a great strength and can be used on taller and taller buildings. And the code has been slowly evolving here in this country to accept that. So that's some of the barriers, right? Just habit and code. But really, I think it's human nature to be wired to be fearful of the new. And so I almost feel like a large part of my job, my daily job, is getting people used to new radical ideas. As I really see all of our jobs as being filters, right? To take these complex ideas and filter them down in a way that people can understand them and relate to them and hopefully get excited about them. I feel like for the most part, sustainability has really come at it from this place of scarcity. We've almost been apologetic. I used to make jokes about this early in my talks where I'd say, "Gosh, is it okay? Do you mind terribly if we don't put cancer-causing chemicals in the building? Gosh, I'm sorry to bother you, but is that okay?" And we as environmentalists kept taking this very apologetic, scarcity-based approach to this. And I'm kind of over that now. My mindset is much more, I've got a better building here. I've got ideas for a better building. Not only is my building green, not only will it save you energy in its operation, but my building will also potentially improve test scores in students. My building will potentially improve patient recovery outcomes in healthcare. My building will potentially improve staff retention in an office and staff productivity. I have, across the board, am offering you a better building. And if it's a matter of cost, then we'll look at the upfront cost, but we'll balance the upfront cost with the life cycle cost, so that way you actually know what you're paying for. We've driven this kind of developer scarcity mindset into everything that we do, and so everybody's so fixated on the upfront cost of the building. And if it costs $1 more, they're like, "No, I'm against it." But the truth of the matter is, that $1 more is pretty well invested, because what we've seen is that for the most part, sustainability features in a building pay for themselves at least 10 times over the life of the building. And so if you're owning the building for any period of time, you're going to want to take advantage of those benefits, especially those outcomes that I talked about in terms of productivity and health and performance and so on.
So that's it for this episode of the Circular Economy Show. We have seen that redesigning the way we design, make, and use the buildings around us is essential to decarbonize the economy, that the circular economy plays a critical role in addressing the emissions from this industry, and what some of the examples of these buildings look like from 2 countries in the world. Thank you so much for joining us for this episode, and subscribe or follow us on this channel you are watching this video on if you would like to get notified every time we go live. And if you've missed any episodes or would like to find out more about what we have coming up, please check our website. Thank you, and see you in the next episode of the Circular Economy Show.